it can be people have the same political leaning, they read the same newspaper, they live in the same block, they have the same level of income, of socioeconomic status, all of these things that will create the intra-class correlation. Then what happened with the variance? The variance under the complex sample will be the variance of the sample, random sample, times this that we call the design effect. That is increased with the greater the size of the sample, the greater will be the variance of the complex sample compared to the variance of the simple random sample. The greater the intra-class correlation, the greater will be also the design effect. Then we have these two elements. The idea will be take smaller cluster and trying to mitigate a little bit that way the level of intra-class correlation that you have in each of the intra-class correlation or homogeneity that we have within the cluster. Then the last element is weighting. We already talked about weighting. We say one of the main source of weighting is disproportionate stratification. If we use disproportionate stratification, we used to have to use weight. But weight is the only variable that will actually appear in the data set. It's a number. Remember when we do the disproportionate stratification, we saw that the weight for men was 16 and the weight for women was 4. Then we will have a variable in the data set called weight, where we will have 16 for all the men and 4 for all the women. Weight will be actually a variable on the data set. But how we calculate the weight? The weight is a correction factor so that the sample become equal. Remember when you said the sample, we call it HM, equal probability of selection. We were always looking that people have equal probability of selection. Then the way to correct the sample so that can happen is by using weight. Then the weight can appear because of this condition. We have unequal probability of selection. We have oversample of minority group. We have what we call disproportionate stratification. One other thing is non-response bias. Whenever we send out a survey, not everybody will answer the survey. Sometimes, but sometimes the bias is not that great. We get, let's say, we get 80% of people answer our survey. Now and there, where everything is online, it takes out that the response rates are even lower. You get 20, 30% answer in your survey. But these 20, 30% that answer the survey, they're probably different from the one that did not answer. Then we need to correct for that. We need to analyze our sample and see if the one that did not answer, if they differ from the one that answered in age and ethnicity, gender, income, place of residence, and use this variable to calculate the rate, a weight that will correct for the non-response bias. Also, life is not so perfect. Even if we do stratify, we do our sample, they probably will still have distribution that we expected. that is not showing in the sample. One of the one of the one of the things we have seen when people do survey is that there is age group that are not that are less likely to answer your survey. That then actually sometimes they are elderly because it's difficult for them to answer the survey, or sometimes there are people that are in the labor market because they don't have time. They're always working. They cannot answer your survey, or if you do it face to face, they're not at home so that you can interview them. If you send the survey online, they don't have time. They probably have kids and working. It's too much for them to answer your survey. The age group will not be represented in your sample. Then whenever you get the final sample, there is things that call post-stratification adjustment, so that you can weight your sample in a way that it shows uh, the correct distribution based on previous study for a non-distribution that you already know. Let's say the idea is if you expect that 20% of your sample will be adult and working age adult, but that's your expectation, but you have a difficult time of interviewing them, you actually get only 10% of them, you can weight your sample that way to correct for this. Then this is these three conditions that will affect. Sometimes there are three different weights, and if you actually go to the enhanced, read the report about the survey, when you start analyzing them, they will tell you each of them are different, and the product of the three of them are the final weight. The three components of weighting, but each of them might be present in your data set, and you should know which one is correct for equal probability of selection, which one correct for response rate, and the product of them are always the final weight that you need to use. But because you multiplying things on your sample by a specific number that is the weight, that's where your standard error will increase. Then we know that weight will always increase our standard error. Sometimes weight is something that is very tricky because you want to correct for things in your sample, but you don't want the weight to take too much of our sample, because if the variance of your weight is a variable on the data set, you will have a mean and a variance. If the variance of your weight it's bigger, it's very big, that means the weight, instead of improving, you correcting. If it's improving, it's kind of distortion of your sample. Then we have to be careful of the weight. Sometimes you have to actually do your analysis unweighted and weighted and see if the tendency. Let's say if I do an analysis comparing gender, I have the unweighted sample and I do it using weighted sample, and I saw there were differences. The differences are no longer there. Then I will say something is wrong with the weight. The weight should help me in getting equal probability of selection, but it should not be that big that it's like eat all my variance, and then my sample the variance becomes so big and I don't get a difference. Then we always have to be careful of the weight, because weight will introduce instability on the data. we have to normalize the rate, trim the rate in terms of the variance are not that big, and they don't eat all the variance of my estimate. Then we have this trade-off when we do an analysis when using rating. Do you accept the instability that you will have in your day, or uh, or do you reject it? If you accept instability, you get less accurate represent, representation. But if you don't accept it, then you correct for it, you get better representation. It's not great, it's why we always have to compare unweighted and weighted and see if there is a difference. If there is no difference, we use the weighted. If there is a difference, we have to analyze the weight variable and try to trim it and correct, normalize it so that we get accurate estimate. Okay, now I have some example. I always say, if you don't know about anything about stratification and clustering, whenever you use a nationwide survey of the US, you should always use weight, because there is no way to do a survey here for the nationwide survey without using disproportionate stratification somehow. Then you will always, to get estimate, use the weight. When I say use the weight, it's always compare unweighted and weighted, but you should always, the first thing that